Okay, good morning. I'll start off by saying I imagine most or all of us here have tried to raise a plant before. And I imagine most of us have seen them wither away and die and not really known why. So we're going to talk about that this morning. First, I'm going to introduce myself. My name is Scott Walker. I'm 33 years old. I work as a jack of all trades handyman, but I've been looking for a change. Back in 2019, I signed up for C&M's electrical trades program and got a couple classes in, and then COVID came around and canceled that. And in 2023, I hadn't gotten back to school, and I heard about this boot camp, and a few people thought I'd really like it, and I figured I'd give it a go, and now we're here. So the problem I'm presenting to you all today, gardening is difficult. Sometimes your plants die. You don't know why. Sometimes they get sick. They don't produce fruit, whatever. And it could be numerous things. It could be the amount of sunlight. It could be their water. It could be the pH of the water. It could be temperatures. It could be humidity. It's a million different things to track. And I know I certainly haven't in the past. So my solution is the Garden Nomad. So you put the Garden Nomad out in your garden, and it sits there and it collects data points. It takes temperature, it'll get the humidity, the ambient light, soil moisture, and we have a way to collect pH values. So with all this, you can, do a little bit better job of keeping the numbers right within your garden. So I'm going to show you a little video demonstration here.
This is my tomato plant, and I'm trying not to kill it. That's why I made this. It's called the Garden Nomad, and it can monitor all of the variables in your garden needed to help keep your plants happy and healthy. Right now, the Garden Nomad is in passive data collection mode. In this mode, it collects ambient light, temperature, humidity, and soil moisture data, which is periodically sent to the cloud. If you could see the display on video, you would see all of these values on the screen. Pressing the Next button will cycle through each individual value so it can be read more easily on the small screen. It also shows the most recently collected pH value. Pressing the Mode button will cycle the device into manual data collection mode. This mode allows you to gather pH values in 3 different ways. You can sample the pH of water before watering the plant. You can also take a soil sample mixed with water and run through a coffee filter to determine soil pH values. Lastly, you can sample runoff water. Simply press the Next button until the display shows which type of sample you're collecting. Place the probe in your sample, wait 15 to 30 seconds, and press the Sample button. That value will be saved and sent to the cloud. Pressing the Mode button again will put the device into Setup mode. This currently has 2 functions. The device is programmed to push an alert if the soil moisture goes below a certain threshold. In Setup mode, you can change the value at which that alert is pushed, anywhere from 0 to 100% soil moisture. Press the Sample button to cycle through values and set your desired number. If you press the Next button, you can do the same thing with the Feed alert. It's programmed to alert you to feed the plant nutrients every 7 days. This number can be customized between 1 and 14 days. The Garden Nomad is battery powered, and the battery is charged with solar power. The solar panel, as well as the ambient light sensor, are at the end of a 2-meter cable, so they can be placed in a nearby spot with the most uninterrupted sunlight. The red LED light is the water alert. If this light comes on, it means the soil moisture has fallen below the minimum threshold. In this case, it means I removed the sensor from the soil. By adding water, or replacing the sensor in the soil, and pressing the red button, you can reset the alert and turn off the light. The Feed alert works similarly, but on a timer. That's the yellow LED light. The last feature that can be seen here is the System Reset button. If something goes wrong, or you simply wish to reset everything to default settings, press this button. It will take a moment to set up and connect to the internet, but should be up and running quickly enough. Here is the dashboard where the data is collected and displayed. Temperature, humidity, ambient light, and soil moisture are displayed as line graphs. These values should be in different ranges for different plants. They can also be controlled to different degrees in different gardening environments. If you don't have the ability to control temperature, humidity, or light levels in your garden, this data can be very useful to help you decide what will and will not thrive in your garden. The pH values are shown on a gauge. The green zone on my gauges is between a pH of 6 and 7, as that is the ideal range for tomato plants. Nearly all of the design and fabrication for the Garden Nomad was done using SolidWorks and a bamboo 3D printer. Here are some examples of the design. The main body enclosure seems simple enough, but I wanted to design it in a way that allowed parts to slot in and stay put without needing to be screwed or glued down. The slots at the back hold the breadboard and battery. I then designed shelving to hold the buttons, lights, OLED display, and the temperature and humidity sensor. The main goal here was to make final wiring and assembly as easy on myself as possible. Next, I needed a lid to protect the interior but still provide access to the screens and buttons. I also created a housing for the pH probe to go on the side of the main housing. Lastly, I created hinges for the front face and the pH probe housing.
Okay, so I'll briefly just go over the components used in this. I think we all used a Photon 2 microcontroller. I had a temperature humidity sensor, a light sensor, a soil moisture sensor, pH sensor, an OLED screen, the solar panel, which goes through a charge controller and charges the 3.7 volt battery, a couple of LED lights, and some buttons. And so I showed you the 3D design at the end of the video. Here's all of my two-dimensional stuff. I scanned in all my notes and stuff. If you want to peruse any of that for some reason more closely, it's all on my Hackster page and on the GitHub. I also did a little bit of laser cutter design. I guess I made a little acrylic cover that I put on before the lid and then cut that on the laser cutter. And of course, I used the 3D printer for the vast majority of it. Challenges and improvements in further development. So the initial challenge was I wanted something that would passively watch your soil pH, because I think that's one of the biggest things that people miss in gardening. After extensive research, I found products that say they'll take soil pH and soil nutrients, and from my research, those seem like they're scams or they just don't work that well. So I had to land on this, which takes manual samples, but it seems to work out okay. The next big challenge was just wiring the thing up. I think we all probably struggled with that. The smaller your enclosure, the harder it is to wire something. This week, we discovered heat casualties. The PLA we use on the 3D printers begins to melt at outdoor temperatures, it turns out. So, and my thermometer picked it up getting up to about 124 degrees. So when I redesign it, and I'll get to that in a moment, I'll use a different, maybe high density polyethylene or something. And then I was concerned about power because it's just got a little battery in there. So it does spend right now about 2/3 of its time in low power sleep mode. And it just wakes up, takes some data, sends it out, and goes back to sleep. And it survives all night, so that's good. And it survived all day yesterday in the rain. Future improvements, a couple small things. That water LED alert I showed you, probably doesn't need a button. That's probably coming out. It can turn itself off. The feed timer, I have it on a 7-day schedule, and the microcontroller stops counting eventually. It can only count so high. So I think I want to change it so it gets that alert from the dashboard. I need to do a lot of weatherproofing and I guess heat proofing as well. And I think I'm going to switch to a boron or an argon. They both pick up the cellular network, which obviously out in a greenhouse or a garden or something, you're more likely to have cellular data than Wi-Fi. And then I wanted to show you guys, I mocked up like a printed circuit board. That it's subject to change a little bit as I change things, but that means I have to redesign the housing around the printed circuit board. So when I do that, I'll solve probably weatherproofing and heat proofing issues as well. And then I just want to make it bigger and better in the future. So now I just want to thank everyone. I want to thank Brian and Reed and EJ for all their help. All my classmates as well for their input and help. My friends and family for putting up with me all this time. And thank you all for being here and watching. That'll do it. Here's all my info on the screen.